this is a Google Colab notebook, and I start program for writing Python program. So let's import the libraries. Import numpy as p, and I will require the plot library matplotlib.pyplot as plt, and test this idea. So for the first cell, Python is going to import the libraries if something is written correctly. My objective is to demonstrate the rounding off error. So I define some values of pi as approximate pi values in an numpy array, numpy dot array. That's the way to create an array. So 3.0, 3.1, 3.14, 3.142, 3.1416, 3.1459. So these are the values. And in Python, we have the exact value of pi as well. So let's write these two: pi expected, pi approximated, and in pi from Python numpy.py. And if I ask the play, so these two lines will be executed. So we have rightfully created the array, and the exact value from Python is also available. Okay, that's fine. So in Python, Jupyter Labs, we can run the code in segments. That's the great facility. Now I define the h values. Not h is not required. Let's define some pi approximation as sine come from the library. We require the vectorized processing, therefore numpy.sine, and my values are pi a divided by 2, right? So this is the calculation we would like to do. This will do the calculation for the whole array PIA, pi approximate values, right? So YA has been computed. Now the Y value is numpy dot sine of Python's pi, which is pretty accurate, divided by 2. So this is the in our case, this is the exact value, and this is the set of approximate values. So in numerical methods or in scientific computing, we always compute approximation and compare them with the best available exact values, or so-called exact values. Sometimes these values are the experimental values. Now the error calculation. So error is equal to numpy absolute of YA minus I. So all values will be subtracted, all approximate values will be subtracted from the exact value. And now I plot the values. PLT dot plot, and I take the values, approximate values of pi. So we know 3 means 3.0, 3.1, they are slightly away from 3. And the error, and I plot it with the red line. and line width equals, and that's it. Let's see the outcome. So the round off error. Oh, so the round off errors tend to vary linearly, right? It's a fair approximation. So 3.0 was the first approximation. 3.0, it is the most away value from the exact value of pi, 3.14159, and for others the error has reduced. So if you are going to use the exact number representation, your errors are going to be smaller and smaller. So let's stop at this point.